Good morning students, welcome to 8th standard physics class. Let us continue our lesson 2, force and pressure. Last class we learned about pressure, but today class we are going to learn what is liquid pressure. So let us recall the last class portion. What is pressure? So pressure is nothing but force acting on the unit area. The unit for the pressure is, the unit for force is Newton, the unit for area is meter square, so unit of pressure is Newton meter power minus 2. So now we are going to continue what is liquid pressure. Not only solid has pressure, liquid also has a pressure. That means liquid also has some force. That force, what we called as a liquid force, we called as buoyant force. That is nothing but a upward force. All the liquid exerting some upward force. That upward force we called as a buoyant force. For example, if you take a liquid in a beaker, this liquid is exerting some force is upward. This upward force what we called as a buoyant force. So this upward force only decides why the objects sinks or float. For example, if you keep some wooden block on this water, this wooden block float. That means the upward force is less for the wooden block. The case of the wooden block, this upward force is less. That's why it's float on the water. At the same time, if you put a stone in this water, the stone will sink. This is a stone that will sink under the water. That means this upward force is very much greater. The upward force is here it is greater and here it is less. That's why because of this less upward force, this object will sink under the water. This upward force is very much high. That was, it will float on the water. So when the object float or sink, that will be decided by the upward force. So if the liquid has force means this liquid is also has a pressure. That pressure what we called as a liquid pressure. This liquid pressure can be measured by the instrument what we called as a manometer. So this instrument has a U-shaped glass tube. U-shape that fixed on the wooden block. That will be clamped on that wooden block and it has some liquid. When the air pressure is given to this one end is very lower compared to the other limb. So when the air is pulled to this liquid, so the liquid will become rises. The difference in the level of the liquid that we consider as a height. This height of the liquid that decide the pressure of the liquid. If the water in the limb is very high, means that pressure is also here it is very high. So that pressure can be calculated by the formula H rho G. H means the difference in the height of the liquid in these two ends, that is height H that we measured by the meter scale, and rho is the what liquid we are taken. Usually they are taking as a mercury. So this mercury density and G is what is called as a gravity. So this is density and this is what we called as a gravity. So these are constant value. When you substitute all this value, we can find out the liquid pressure. So the liquid pressure is not only calculated, liquid has pressure can be explained by the one more experiment. That activity we are going to see that activity we can see now. the liquid pressure activity. You take a U-shaped glass tube and one end is very lower, the other end is somewhat higher, and you pour, and in the lower end you tie a balloon and you pour a liquid in this higher end. When you pour the liquid moves up and slowly the balloon is bulges. So when the liquid level is very higher, the portion of the balloon is also bulged more. So this bulging of balloon, what it indicates, the liquid has giving some pressure to the balloon so that the balloon will become bulger. So from this we can understand the liquid pressure. That you can try it in your home also. Take any glass pipe and fix one end here and pour the other end. Automatically the balloon bulge. That indicates that the liquid has a pressure. That you can try. And one more property for the liquid pressure is it has this pressure. Liquid pressure is greater at depth. That means when the liquid pressure will become very greater at the depth, when the depth increases, pressure is also high. Pressure is also increases. And particular depth, that pressure is constant. Pressure is same. At a particular depth, the pressure is same. That we can explain by this activity. In this activity, you take any glass bottle and fill this bottle with the water, and you put 3 holes on the same depth. At same height, you put the 3 holes. And you pour the water and you give some pressure on this side. If you give this pressure here, the water comes out all the 3 holes at the same amount. That we can indicate that at a particular depth, the pressure will become same. So this activity also you can try. Thank you.